At the outset, let me express my heartfelt gratitude to you for giving me this opportunity to interact with the participants. Well, friends, I have been asked to speak on geographic information systems. And geographic information system is the state-of-art technology today. And I was seeing the schedule of this course, and I found that you have been exposed to remote sensing, various sensor platforms, GPS, and now GIS. Remote sensing, GIS, GPS are the state-of-art technologies, and these are buzzwords today. GIS, let us try first to understand this acronym. There are three words: geographic, information, and systems. Now, each one connotes a very, very specific meaning. When you talk about the first word, that is geographic, it has to relate itself with the location, geographical location. Now, geographical location is the key concept when you have to understand the entire concept of geographic information system. Now, all of you know that no two places on the earth will ever have the same location. They may have same climate, they may have same altitude, they may have same latitude, they may have same longitude, but not the same location. Location is a function of latitude and longitude. That is what is called X coordinate and Y coordinate. The word information suggests that when we work with this technology, we are going to work with some data, and that data will be used to cull something more meaningful out of it, and which will become information. You all have to be very cautious that there is a difference between data and information. When you cull something more meaningful out of a data set, that becomes information. And in geographical information systems, you are going to work with different data sets, which we are going to elaborate in detail, and you are going to cull out information out of the data used. Now look at the third term, systems. The word system here means that you are going to use computer as a system along with its hardware, software, and peripherals. And computer is to be considered as one of the most important elements in the geographic information systems. Now, this is the layout of the presentation today. I shall be dealing with introduction, what is GIS, components of GIS, types of data, tools of GIS, the functional elements of GIS, the benefits of GIS, and GIS as a multidisciplinary science, highlighting some of its applications. Now let us start with the introduction of this technology. Almost everything happens somewhere, and in most cases, knowing where something happens is critically important. For example, it could be a position of a country boundary. Look at the conflict we are experiencing with China over the LAC issue. Location of hospitals. The Delhi administration and the administration of all the districts and cities are running out for the location of hospitals in this COVID emergency. You need hospitals. You need to know where are the beds left. There has to be a database on it. Routing delivery vehicles. The police personnel would love to have a database and an application which gives them a shortest route to reach where crime occurs. Management of forest stands. Look at the forest fires we have, and we lose so much of natural resources. Allocation of funds for sea defenses. Now, in all these examples, one thing is very important, and that is the locational element of all these phenomena. Geographical information systems, as I said before, is a special class of information system that keeps track not only of events, activities, and things, but also of where these events, activities, and things happen or exist. Geographical location is an important attribute of activities, policies, strategies, and plans. And that is why geographical information system has become one of the state-of-art technologies today. Geographic problems involve an aspect of location, either in the information used to solve them or in the solution themselves. If you have to solve a problem which is rooted in its location, the solution shall lie in the application of this technology, because the location is one of the most important aspects to be taken in this technology. Now let us see what is GIS. Now GIS is a structure which contains spatial information along with its non-spatial information. Now these are two very important terms to be understood. Number one is spatial information and one is non-spatial information. Whenever you work on a location, whenever you work on a place, the geographical coordinates, the XY coordinates, the latitude, longitude is its spatial information. And the attributes which shall form the data on which you want to work is considered as non-spatial information. We shall deal with spatial data and non-spatial data in detail in these slides to come. Second aspect is that GIS is a system used to capture, store, manage, and analyze spatial and non-spatial information. Now, when I say capture, store, manage, and analyze, these are inherent functionalities of a computer system which are automatically driven to GIS. Third is an aspect which says that it is a computerized data management system which is used to retrieve and display spatial information and non-spatial information. Now, when you're going to deal with computer as one of the most important functional element in the GIS technology, it helps you to retrieve the data at your own will. Whenever you want, you can retrieve the data. Whenever you want, you can display the information. And this information, whether it is spatial information or it is non-spatial information, will come from the analysis of spatial data or non-spatial data. In the coming slides, I shall make this thing very clear to you. Now, if we have to define geographical information system, how can we do that? The geographical information system has the ability to store, retrieve, manipulate, and analyze a range of spatial related data. With a GIS, the user may ask questions of data related to the map, search for patterns and distributions, and investigate the underlying relationships between different sets of data. Now, this is the beauty of a GIS software. You have spatial data on one hand, which speaks of locations, connections, and you have attribute data, which we also call non-spatial data. And when you are able to use a GIS software, it links the two. And when the spatial data is linked with the attribute data, you are able to understand number of relationships between the spatial and the attribute data. And GIS handles this joining of data very quickly and very efficiently. It helps you in the mapping facilities that may have taken many hours to complete manually. When GIS technology was not much in use, maps were being made. They were being made by cartographers manually, and it would take a lot of time for them to make those maps. Today, we are very quick and efficient in making those maps using this technology. Next, GIS is a computerized data management system which is used to you can capture any amount of data, whether it is spatial or it is attribute. You can store it. And if you find that some data has gone redundant, you can do away with it. This is how you manage it. You can retrieve the data whenever you want, at your own will. You can analyze the relationships which the spatial data and the non-spatial or the attribute data has. And here lies the beauty of the GIS technology and softwares, which help you to give an analytical ability to analyze the data and cull out information from it. You can display the spatial information along with its attribute information. Now, this is what a GIS can be depicted as. You have the information system on one hand, you have the geographic position on the other, and the wedlock between the two shall speak what GIS is. A GIS information system provides the capability of integrating the information system with the spatial data or geographic position to solve the real world queries and problems. Now, these words are to be remembered. It has come to solve the real world queries and problems. That is why it has become the state of the art technology. If you are working with a real-time data and you have queries to answer, you have problems for which you want to seek solutions, Geographical information system is the panacea for most of these queries and problems. Now let us try to see what is GIS composed of. That means when we say GIS as a technology, when we use it, what are the basic components or the functional elements? Now, a GIS can be divided into 6 components: people, procedures or methods, you may call it, hardware, software, data, and network. Now, what do we mean by people? The people are the viewers, they are the general users, and they are GIS specialists who are into making of these softwares and coming out with various modules on GIS capabilities. Now, what do we mean by procedures? These are the steps which are taken to answer the question which need to be resolved. Every module in a GIS has a particular procedure, and you have so many tutorials, and you can educate yourself. There could be a trainer who can train you. Then you need hardware. Hardware requires a computer system. Software, there are different GIS software packages: ArcView, ArcGIS, QGIS, and you can have GeoMedia, Map Info Professional, Global Mapper, Manifold GIS, NV GIS software. There are n number of GIS softwares, and these days you have a number of online GIS softwares. Amongst them, QGIS, Quantum GIS, is very, very popular. It is a C language based. Then another popular online GIS software is GraphGIS. It is Geographical Resource Analysis Support System, and it is used by US Army. Then you have GeoTools, GeoServe, OpenMap, SharpMap, Whirlwind, and there are n number of softwares. When you are trying to use a GIS software which is offline, it is ArcView and ArcGIS, which is recommended, and it is manufactured by ISRI, Environmental Systems Research Institute in US. And when you want to go for an option of an online, it is suggested that QGIS or Quantum GIS is one of the best choices. Next, we need data. Data statistics, which are very, very crucial to check the quality of the data before obtaining it. Now, you are going to work with two data sets in GIS. One is the spatial data, which is going to be related to the locational or the positional or the connectional aspects of the data. It has to be very, very accurate. Next, you are going to deal with attribute data. And attribute data will be based on the attribute of a location which you have chosen to work. These attributes could be anything, keeping in mind your area of interest, your area of research. Suppose if you are working on population statistics, the census data is there for you. You can use the data in terms of literacy rate, sex ratio, number of households. Somebody working on economic data would work in poverty ratios, but all these data have to be location specific. You should have these data linked to a location. May it be a village, a district, a city, a town, or even a country. Network means that you combine all this above to make a system. And this is what the word system stands for in the geographical information system, and the network, and the main element in this network is the computer. Now, this is how I can represent components of GIS in a diagram. So you have people to begin with. You have GIS software. You have a GIS software. And this GIS software enables you to work on the attribute and the spatial data. And this GIS software has another beauty of integrating the spatial and the non-spatial or attribute data. Then you can have data. Data could be spatial as well as attribute. Then there are certain procedures This is what is required to get a training to use a GIS software, so that you are exposed to all the procedures, modules, how do you run them, what are their capabilities, and what are their shortcomings. And of course, the hardware, which includes a computer system. Now, GIS in itself is a huge system containing few broad subsystems. The broad subsystems are data input subsystem, which means you need to pre-process the data, you need to transform the data many a times. You need data storage and retrieval subsystem, and this data storage and retrieval in your computer, when you have a very strong RAM, lets you organize for retrieval, editing, and updating at your own will. Data manipulation and data analysis would require aggregation of data many a times, disaggregation of data many a times, and modeling the data many a times. Modeling means simulating the parameters in order to see the futuristic behavior of many of the variables. When a model walks on a ramp, he or she is trying to tell you that if you wear the clothes I'm wearing, you would look something like me. Similarly, you can apply the modeling in data. You can go for flood modeling, where you should have data on the amount of rainfall. You should have data on the discharge of the river, and then you can simulate the reality in your lab, that if X was the amount of rainfall and Y was the amount of water in the river, when did the river inundate and how much did it inundate? You can increase and decrease the value of the rainfall and see if more rainfall is there, how much area would be flooded, and vice versa. Reporting. That is the output. And the output could be tabular, it could be graphic, and in most of these systems, the desired output is a map. And a map, I must say, is a very, very strong tool of communication. Even if you are trained in using GIS, you should have an adequate knowledge of cartography. Cartography is the art and science of map making. If you are able to design a map and that is not understood or is intelligible, there is no need, there is no purpose of making that map. So you should know, when you make a map, what are the elements of map making, and you should know basic elements of cartography so that you are able to design a map. A map should have aesthetics and a map should have objectivity at the same time. Now, there are a number of geographical information systems available today. They range from high-powered analytical softwares to visual web applications, and each of those are being used for different purposes. Due to the vast number of GIS available, it is simply not possible to provide training for each individual software here. However, there are common features in all GIS softwares, and understanding these basic features will give you confidence with any GIS system that you are going to use in the future. There are three types of GIS systems available. One is web-based, online navigation system, for example, the London Profiler, GeoBrowser, that is the Google Earth. Then you have desktop GIS, ArcGIS, and you can have online GIS as Quantum GIS. Now, this is very, very important to understand, what kinds of data you are going to use in GIS. Now, when I am speaking of data, I essentially mean the different data sets you can work on. Geographical information is different from other kinds of information, and therefore it requires special methods to be analyzed. Some of the characteristics that make geographical information special is this. Number one, multi-dimensional. At least two coordinates must be specified to define a location, X and Y, latitude and longitude. Voluminous. A geographic database can easily reach a terabyte in size. Different representations and how it is done can strongly influence the ease of analysis and the end results. You should be knowing how do you represent the data both graphically and by making a map. You need to require an understanding of the projection. Now, projection is a means of transferring the graticule. Graticule means the grid. Graticule of latitudes and longitudes onto a flat surface. Now, projection is that technique by which the grid or the graticule of latitudes and longitudes, which are on a sphere, because the Earth is an oblate spheroid, when you try to transform the graticule from a sphere to a plane surface or a flat surface, it requires a number of calculations and changes to be done. And this is taken care by projections. And the map projections are of different sort, and one should have an adequate knowledge of the map projections. Now, GIS softwares will give you capability of unique analysis methods. These are data analysis. And these are data analysis capabilities of any GIS software you use. Now, when you use GIS softwares, you can go for overlay. You can go for buffering. Now, these are some of the GIS analysis tools which you will find in most of the GIS softwares. Now, what does overlay mean? Overlay means when you superimpose one data set on the other. Now, when you're working in GIS environment, each information or each data set you work is called layer. What is this called? It is called layer. Now, you can have several layers of informations working in a GIS technology, and when you try to superimpose these different layers, you call it overlay. And this overlay will definitely give you an answer to your problem which you have posed. Suppose you want to know whether the physiography of an area is responsible for the distribution of population. You need to have two layers. One, the physiography of a said place. The second, population distribution. Now, if you have these two data sets and you ask the GIS software to overlay, it will superimpose both these themes one over the other. And then it becomes so easy for you to see which are the habitable areas or which are those physiographic conditions which play a role in the habitability of population. Now this is overlay. You may have 2 layers, you may have 3 layers, n number of layers. Second analysis is buffer. Buffer means a zone of interest. These days, in the COVID situations, you are hearing this word very often. We are trying to create a buffer around a containment zone. Buffer of 1 kilometer, buffer of 2 kilometer, that is the area of interest. The administrator wants to bifurcate those areas. He wants to isolate those areas which are the COVID hotspots, and allow around the COVID hotspots, if you want to draw a buffer of 500 meters, 200 meters, 1 kilometer, you can, provided you have a map of that area and you have a location for those COVID hotspots. And then when you have those COVID hotspots, and when you have those COVID hotspots mapped on the map of that city, for example, you can draw buffers using GIS software. You just have to give a command, draw a buffer 500 meters. Analysis generally requires a lot of data integration. And this is what I was emphasizing earlier also. Now, this integration of data is the integration of the spatial and attribute data. Spatial data is your locational data. Attribute data is the data which you have collected for different attributes of that particular location of which you want to draw an analysis. And the GIS software is going to integrate the spatial and the attribute data, and this is known as linking of spatial and attribute data or data integration. Data updates are also expensive and they are time consuming, but that does not mean that you can not update the data. You can update the data, and that is one of the biggest advantage of using this technology. Whatever is redundant, do away with, and whatever is in, you can add either to the spatial layer or to the attribute layer. And map displays are the final output anyone would like to have using this technology. And for this, you must have fast data retrieval. Now, these are the types of data. When you talk of data, it is spatial data and non-spatial data. And when I say spatial, I mean locations. And the spatial data could be stored in 2 different models. It could be raster, it could be vector. And the non-spatial or the attribute can be arranged in the network form, in the hierarchical form, and in the relational form. And when you talk about the spatial data, for which you have 2 data models, one is vector and one is raster. The vector data models represent the data or the spatial data in the form of point, line, and polygon. Lines are used for data which show connections. If you are working on the aerial dimension, you use polygon. And if you are working on single dimension, you use point. These are interchangeable also. The point becomes an area polygon many a times. For example, if you are working on the cities on the map of India, each city would be shown by a point location. This is the macro picture. But if you decide to work on one of the cities, say Chandigarh, and you start working on the map of Chandigarh, which is a sector-wise map, it becomes an area and it becomes a polygon. Similarly, you have another data model which is known as raster. Raster data model is the data model when the spatial locations are shown in the form of pixels. A point becomes a pixel. A line becomes a row of pixels. And polygon becomes a group of pixels. It could be continuous, it could be discrete. And I'm very sure tomorrow you have a lecture on the database management system, and the response person is going to elaborate these terms. Now, this is what I mean when I say spatial data. And these are the representations of the spatial data in the raster and the vector data models. When you see the vector, you can see the clear aerial demarcation, whereas the same area is depicted in the form of pixels. In GIS, vector is a format which stores information about any feature of the earth in three different types or objects: polygon as regions, lines and arcs, and point as points. The start and end point of a line are called nodes. Any change of direction on a line is a vertex. Lines are joined by sharing a common node, and polygons are joined with their adjacent if they share a common line. Whenever you have vector objects, they're all created from general graphic representation of single XY coordinates. That is why point will be a single set of XY coordinate, whereas line will become a string of coordinates and polygons will be a closed string of coordinates and often composed of multiple lines. Now this is how point as single XY pair, lines, nodes at the beginning and end, vertices for changes in the direction along the line, and polygons is a set of lines. One can clearly see what points, lines, and polygons are represented in vector data, or vector model. Now this is the raster. It is in cells or pixels. It is a set of rows and columns that form individual cells, and each cell has a unique data value, and it clearly has area coverage proportional to the cell size. That is why raster cell is also called pixel, picture element. Raster data is also known as grid data, and it can represent the surfaces or the fourth type of features. That means if you have the fourth dimension or volume, the raster data can be used. Otherwise, it is a cell-based data category that could be included as one of, if your remote sensing satellite imageries. I'm very sure Professor Krishnamohan must have shared or Dr. Vishwabandhu must have shared satellite imageries with you. The satellite imageries are a raster form, and so are the aerial photographs. Now, this is what a discrete and continuous raster data looks like. When you have a map of districts, now this is a discrete data, and you can show those different districts using different colors. But if you have a map showing elevation, this is shown by elevation contours, and this is an example of continuous data. And this also could be depicted in different colors. You can drape one set over the other. Now, when you talk of raster data, you can have thematic data, which is based on the theme or multiple themes. And you can have spectral data, what you have in the imagery. Now, you can create a digital elevation model out of this data, and this is DEM, and the capability rests in a GIS software. And this is how you can create a digital elevation model. Now, spectral data includes data captured on different wavelengths. One wavelength is suitable for few types of features, producing one data layer. Another wavelength is suitable for another type of features, and so on. I'm very sure the lectures on remote sensing and satellite imageries must have covered all these aspects. For GIS, remote sensing becomes a data source. You can acquire data from remote sensing sources. And when various data layers, as I told you earlier also, that you have different data layers, and one layer means one different set of data. And if you have different data layers, you can combine them in the GIS software. And if you are trying to take those data sets from the remote sensing sources, you can have different spectral data, and you can combine all these spectral layers of the spectral data to find out a final layer of information which can help you to answer many questions. Now, this is the difference between vector and raster. Now, when I say the raster view and when I say the vector view, this diagram in the middle column shows the real world spatial entities. For example, if it is a hotel, the representation of a hotel in the raster view would be in the pixels. And if you are trying to show those location of hotels in the vector, it is going to be a point. Similarly, suppose it is a sky lift and you want to show these sky lifts using raster and vector. In the vector, they are going to be connected nodes or lines, whereas raster, it is going to be a string of pixels. Similarly, when you talk of the polygon or the area dimension, and if the forest is an example, look, how do we represent forest in a raster format and in the vector format. Vector is going to be an area which is going to be an enclosed polygon when you join all the points together. Similarly, if you have network of roads, see how network of roads would be depicted in raster. You will have pixels. And similarly, in the vector, you will have arcs and nodes. Similarly, when you talk of the surface or the elevation, The raster is going to show you the difference as you showed in the earlier slide also, whereas the vector representation would be something like which is shown here, and you will have different elevation areas, but those areas would be bound by points. Whereas in the case of raster, it's going to be a continuous, you see increase or decrease in the elevation. Of course, using pixels. Now coming to non-spatial data or the attribute data. Any attribute information, if it is related to features like building, construction material, building's height, building's occupancy, which can easily be recorded in a tabular format and is attached to the feature when you open in a GIS environment, becomes the attribute data for that particular location. And these attributes are alphanumerics, and they are an additional information about each spatial feature you are trying to work in a GIS format. Now these, when you look at this picture which shows different colors, 1, 2, 3, now this is a spatial data, and the attribute for that same spatial data could be seen in the form of tables. For example, polygon 1, it has an ID. The first column has polygon ID, the second has area, the third has perimeter, and these are the attributes. You can have another table which has the point ID and its X coordinate and Y coordinate. Similarly, you can have grain size if you're working on the soil profile. If you're working on the sedimentation, you can have the data. So each area on the spatial entity which shows locations will have a corresponding attribute data which is shown in the form of tables. And these tables could be at different places, and they can be joined together, probably provided they have a common column or a common key. And this is beauty of the relational database of the attributes. Now, relational database is a data management system or is a model trying to manage the attribute data. And in this case, the entire attribute information is in the form of rows and columns. And when you have these rows and columns, it gives you an advantage of updating the data very easily. If you have to remove something, if something is redundant, you just do away with that column or row. If you have to add, you can add a row or a column. Now this is how you update the attribute data. And if the attribute data is in a tabular format in the relational database, these days most of the GIS softwares support relational database. Most of the attribute information will be taken by the softwares in the form of rows and columns because it is easy to work and update rows and columns. Now, these are the tools for GIS. As I told you, the information can come from the remote sensing data. The satellite imageries are a very, very important source of spatial data. Aerial photographs, maps, any kind of geographic data which you are able to procure a map from any of the agencies, whether Survey of India or NATMO. NATMO is National Atlas Thematic Organization. Survey of India, everybody knows that Survey of India is the agency in India to give you maps. You may have maps prepared by town and country planning departments. So these are sources for the GIS data, especially the spatial. The attribute data will have the sources as per the application, as I've already told you. If somebody is working on soil profiles, the attribute data has to be different. You will have different, you can collect data of your own and you can enter into it. You can use data or a secondary data. Suppose the census has collected data and you want to work on population data sets. It is going to be secondary data. You can collect your own data and you can use it in the GIS as an attribute data. And hardware, all of you know, is computer, digitizer, scanner, printer, and plotter. Software is you should need to have desktop GIS or internet GIS. You can have CAD software and database softwares. If you have multimedia, photos, videos, 3D models, you can integrate them. And let me tell you, 80% of the geographic data collected is associated with some location in space. And this has enhanced the utility of GIS with government mostly. Because when the government is trying to collect data and the location or the spatial elements are there in the data, the government can use that data for any kind of decision supports. And that is why many a times GIS is also known as decision support system. It enables you to analyze data and it enables you to take decisions which are not subjective but very, very objective. If you are trying to locate a school in a village, and if you do a site suitability analysis, trying to take a number of parameters to find out the best location of the school in a village or in a district, let me tell you, it gives you a chance to work on objective criteria. And when you suggest that site by going in for a site suitability analysis, nobody can question it. It is neither one politician is pleased or another is annoyed. Whatever speaks, it speaks of the real-time situation. And these information attributes or the characteristics can be used to symbolize and further insight into a given location. Now, map symbolization is something which all the GIS users need to understand. You see, the output you are going to get after using this technology is going to be in the form of a map. And what is a map? Map is an abstract of the real world. Now, when you have to abstract the reality, or when you have to abstract the real world, you are left with a choice to go for symbolization. That is why you need to understand what is to be symbolized with point symbols, what is to be symbolized with line symbols, and what is to be symbolized with aerial symbols. The entire GIS philosophy is based on this simple principle: point, line, and polygon. You need to understand what can be abstracted as a point, what can be abstracted as a line, and what can be abstracted as a polygon from the real world situation. And then the system will give you a seamless operation and linking whatever information you have, either geography or oceanography, climatology, whatever you have, provided you have hardware, you have networks, you have software, and the operational procedures are known to you. And not only just software, not only map making, but you understand the entire dynamics. Now, these are the functional elements. That means if you have to function in a GIS environment, what all do you require? Well, the first is the acquisition of data. Once you have acquired the spatial as well as the attribute data, you need to digitize it. Digitizing means you are trying to convert the entire spatial data into a form where the computer will be able to read its X and Y coordinate. That means you are trying to rasterize the entire data. Then you need, when you are digitizing a map, there is possibility that you are going to commit an error. Detection of errors and correction of errors is known as editing. You need to build topology. What is topology? Topology means how would a computer understand what is to the left of it, what is to the right of it. That means these mathematical relationships in terms of position and location is known as topology building. The software does it for you, but you should be knowing what all this means. Projection transformation. Yes, you're transferring a graticule and you should know which projection transformation is the best. Because when you use the software module asks for all this. We in India generally prefer UTM, Universal Transverse Mercator. Then you should know the format conversion and how do you assign attributes to the spatial data. The pre-processing stage is there, whether you try to convert the analog to digital or you have to convert some of the units. You should be aware of this. Then you have to manage the data because you're going to work on many of the data sets and the data is going to come from different sources. You will have different archival databases. They will have different data models. You should know how to manage them. If you're working on a hierarchical data model, if you're working on relational data model, the fundamentals should be very, very clear to you. But these days, most of the softwares, they work on relational databases. As I've just told you, they have their formats arranged in rows and columns, which you call a table. And where you have an intersection of a row and a column, you call it as a tuple, which is a cell in the Excel sheet. Now you need to manipulate and analyze the data. This is what the GIS technology meant for. When you want to analyze the data, you have to go in for the various analysis tools, whether it is buffering, whether it is overlaying. You are trying to understand the proximity, you are trying to understand the connectivity operations, etc., etc. Now, the most important is the output. After using the entire technology, what is the desired output you are thinking of? Yes, it is a map, a thematic map which you will construct or create. You can have a three bird's eye view also. You can have scaled maps. Scaled map means you need to have a scale. If your map doesn't have a scale, it is not a map. And scale is the ratio between the ground distance and the map distance. If you don't have a map with a scale, it is a sketch then. So when you are generating maps, most of the times your output is going to be in the vector form, because raster maps will be very ugly and the vector maps are going to be more precise and beautiful to look at. So your output has to be a vector output. Once a GIS is implemented, following benefits are expected. It's a better maintained data. It is a standard format, easy revision, easy updation. It's easy units conversion, easy to share, easy to search, analyze and represent. You can add many value added products to it. You can enhance productivity of the staff, time and money is saved. And above all, GIS promises a better decision making. And that is why it is becoming very popular with the governments, and they are using GIS as a better decision making tool. That is why it is known as decision support system. During the COVID preparedness, the NIDM, National Institute of Disaster Management, and NDMA, National Disaster Management Authority, they have used the real-time data of the COVID-affected patients, trying to locate them, and they are working on real-time data, and then they are trying to see, they have collected data on certain parameters. They are trying to join these parameters with the locations, and then they are trying to classify them into red zone, orange zone, green zone, and then they are trying to take a decision which ones are to be kept in isolation, which one will have a second lockdown, which one will see a relaxation in the given provisions. So the government is using GIS for taking a decision because it's known, because they know they will be equipped with much better decision-making capabilities. Now, GIS is a combination of various sciences. You have geography, statistics, cartography is art of making maps. You have remote sensing. Most of the remote sensing and data can be used as input in GIS, photogrammetry. You see, those principles are used in GIS, computer science, operations research, mathematics, all modeling, simulation, which you do is from mathematics. People are modeling when is the COVID peak is going to, arrive. It is all on the real form, real information data. And of course, location data is there. Civil engineering, geodesy, environmental planning, urban planning, etc. These are certain softwares. As I told you, ISRI is there. You have ArcInfo, ArcView, ArcGIS. GRASS is online software. Then this is an IDRISI by Clark University. ILVIS is there, Integrated Land and Water Information Systems. And you have Quantum GIS, as I told you, QGIS. And these days, this QGIS is becoming very popular because their modules are very, very user-friendly, and you should definitely lay your hands upon this. Well, use of GIS has many advantages because it explores geographical thematic components. It is integration of data, and you can use from various sources, and then you can integrate them. It allows variety of forms of visualization, but then there are certain limitations because it's very expensive to use the desktop and the computer, the server, versions of the GIS. And the learning curve of GIS software can be long sometimes because it takes time to get equipped with those capabilities. And the spatial relationships, many a time, they do not provide absolute locations if you do not have adequate data. And most of the origins are in the computer sciences, so solutions may not be very, very appropriate for humanities research. But these days, this limitation is being overcome because most of the humanities research is also trying to learn, from the various sciences, and they are trying to use this for example, most of the data on crime, or the researchers who are working on crime, they are using GIS. Earlier, nobody could think that the sociologist working on crime or the crime specialist or the geographers working on crime, they would use this. But today, GIS has come out to be a very, very important tool for crime analysis because it helps you to identify the crime hotspots and the trajectory of crime, and the police is using the routing applications. So The interdisciplinarity and the multidisciplinarity of various subjects is making GIS one of the most popular technologies. Thank you. Thank you so much.
Thank you, madam. Thank you for a wonderful presentation. You have given the gist of what the GIS includes. Now we have few questions listed on the chat box. Madam, if you can open up a chat box, it will be easy for you to read the questions and then reply back.
I'm end slideshow. Yes, chat box.
इसको आप पहले बंद कर दीजिएगा.
बंद कर देती हूँ मैं. Okay.
Ma'am, what are exactly thematic maps? Ma'am, one question from Dr. Siba Sankar. What are
you speak out the question to me?
Yeah, one question from Dr. Siba Nayak. What are exactly thematic maps? What kind of data we get from there?
Thematic maps?
Yes.
You see, thematic maps are the maps which try to focus on one theme at a time. One theme at a time. Maps are of different types. When you are trying to create a map using one theme at a time, it is a thematic map. Suppose you create a map on the soil distribution. It is a thematic map. That means one layer of information would be shown on the map. Yes, another question?
There is another question by Sunny Tourke. Monica, पढ़ दो.
Yes, ma'am. Cluster analysis and crash black spots can be plotted in ArcGIS software. Can cluster analysis and crash black spots can be plotted in ArcGIS software?
Yes. Cluster analysis can be done.
Okay.
Any other question from the participant? If no question, then okay, ma'am. Thank you so much for your presentation. You can exit. You can exit now, and request all the participants to please, fill in your attendance. आप link upload कर दो, Monica.
Okay, yes, sir.
Okay.
Attendance link is in the chat box. Kindly mark your attendance, participants.